Hi, my name is Marcus Parsons. I'm Industry Solutions Director for Food and Beverage at Emerson Automation Solutions. And today we have some exciting news to share. We have a new palletizer health application that we are working on in partnership with Bussey Arrowhead. And essentially what this is doing is it allows you to do predictive maintenance on palletizer systems. So we're able to monitor pneumatics and vibration to be able to predict the health of the system and to let operators know when there's an issue and how they might resolve it. This is very important for our next generation of workers, as they may not be as used to this equipment as seasoned operators, and it allows them to know right away when there's a problem that needs to be solved. And now I'd like to introduce to you Chris Noble from our Fluid and Motion Control Division to tell you a bit more about the technology. Chris?
Thank you very much. Thank you, Marcus, very much for the introduction. What we see here is a dynamic screen. This is the opening screen that we have. It's basically an overview of all the systems in place. We have a feed-in area, which then feeds into a sweep. These would be cans that would feed in. Below this, there's some pallets that basically de-stack down. As new pallets come in, there's sheets that then pull, that go in between the layers of cans. What we're doing is we're monitoring the overall health of all the assets that are inside of this machine. We're specifically focusing on the sweep and on the bed area, which actually has a motor and a bearing assembly that provides air that helps to move the cans forward. So let's take a closer look at what we're monitoring in each one of these areas. So the whole key in what we're trying to address with customers is improving overall throughput. And so what we have right here is we're pushing about 240,000 cans per hour through this system. The actual value we're trying to hit or maintain close to is 250,000 cans per hour. So with that, we have the main control center here showing overall flow of the sweep area, overall pressure, overall vacuum. As we get down here, we have all the air cylinders that are part of this machine that are labeled to give the operator very clear, independent viewpoints of each one of those areas of the machine. So if there happens to be an issue, they can come down here, they can see that a gauge maybe changes, the health status degrades, they can come to that specific area and attack the problem. As we go through here, what you're seeing specifically is retract, extend, and the overall time that it takes for either an air cushion or the overall stroke of the air cylinder to give us a velocity measurement. And for whatever reason, some of these gauges happen to be off. What that allows us to do is quickly pick up on either a green status, a yellow status, or a red status of that particular area of the machine or that actuator. As we get farther down into this, as an example, the stagger plunger, you can see status is good, but if for some reason we got a red status, turns out the retract shock is going bad, we can actually click on that shock. This will actually take us into an area that gives us more information with a PDF file, all the specifications, and if there was an immediate need, we can come down here, we can see 18 days for delivery, and we can see what the price would be on that. So now this ties nicely into your ERP system as well. Okay? We're going to back out, take a look at one more area. When we go to the bed, where now we have a vibration sensor that is set up. Right here we have from Emerson the 9420, which is a wireless heart device which ties back to a gateway inside of the cabinet. We have two sensors here. One sensor picks up motor vibration, the other sensor is picking up bearing vibration. So down in this area here, we can see we have bed vibration gauges. I click on that. You'll see a series of gauges now. As this motor is running, you can see peak values, you can see bearing velocities, you can see any sort of bearing peak velocities and such. And you have a little bit of a historian down here that's kind of keeping track of where we are on an hourly basis. So we're looking for any sort of changes over time. And that's what helps us to record and know that we need to cut something off before it happens, or that the overall health status is excellent, okay? Case in point, this was actually the second machine that we worked with Bussey. On one of the first machines that we worked with, there was a bearing that was actually going bad in the plant. And what was interesting, there were about 20 people in the plant that could audibly pick up on that sound. For myself and others that were new to the system, we had no clue what was going on. It sounded normal to us. But because we were able to look at some analog information and actually see that the peak values are well into, say, the 600 range versus the 3 range that you see here, we knew something was wrong. And that was exactly the case in point what we're trying to prove with Bussey with our customer base that we have a very simple system we can install, actually based on 3 sensors overall to pick up over 100 points of information off of this very, very large machine. Okay, thank you very much for your attention, and hopefully we'll talk soon. Thank you.